So, as I had already explained to you guys, all right, from your charger, no? There, you can write it charger there. Power comes from your charger as your positive and your negative. So you don't really have to worry about negative because the whole motherboard is negative. If this is a negative, that's negative, all of it is negative. So you shouldn't really worry about that. What you should worry about is having negative on your positive. That's called a short circuit. Simple, as I've explained before. So, from your charger, you get your charging port, which is this one here, in this particular case. You can see the customer has already tried to change the charging port. Why? I don't know. Anyways, from the charging port, I explained, most of the machines, it's either they'll put a fuse or they'll put an inductor just after the charging port. In this particular case, there, you've got two inductors there. We measure in beep mode. And the pin is gone again. Why did I leave my multimeter at home? Anyways, let me improvise. There, from the charging port, you go there's a beep, which means power is coming from this positive to there. If I put ground here, you see there's no ground, because that's your positive. But this is your ground, everything. It beeps, and that's your positive. So your positive from here, it's going to those two inductors. Check the 19 thing there. Wait! Because I think that's why you guys are getting lost. So from this inductor, then I explained, from there it gets to what? It gets to the first MOSFET, which will be Q1. Then the second MOSFET, which will be Q2. Of course, when you're now on the motherboard, it's not written Q1, Q2, it's written another one, but it will be Q something. Then from the second MOSFET, I explained, it goes to your what? To your current sensor resistor. There, which we will name R1. From here, this is now your main power rail. There, so it's as simple as that. You've got what? You've got your charger, from charger, charging port. Charging port, you get your fuse or inductor, one of the two. Then you get first MOSFET, second MOSFET, main power rail through the resist, the current sense resist. That's how it is. So when you were taking this motherboard, you were supposed to find these components first before you go on and tell me that this inductor is the reason why the machine is dead. This inductor has nothing to do with that. I think it's related to the Type-C charging port or something like that. So I don't know why you were there in the first place. Even when you measure there, try to find ground there. There is no ground, there is no beep. So how did you conclude that those inductors are dead? And you even named them capacitors. How can you name them capacitors? It's written there, PL103. L, inductor. That's why I said you guys are not taking this thing serious. Now I'll continue with my business and forget you. Anyways, it's a simple thing. Where you see a MOSFET and another MOSFET and a resistor. MOSFET, resistor. That's what you're looking for.
Can you please show me
on this motherboard? The charging port goes there. When you check there, you've got what? Inductor, MOSFET. There, you can see it. Let me put it on camera there. Charging port. Let me make it more clear. There. Got your charging port. There is the inductor, MOSFET. It's always going to be the same. Not the same exactly, but that's the general rule. So when we're looking at this particular one that you guys were working on, there you can see your charging port. There is a charging port, inductor, MOSFET, resistor. I can see where you guys got confused. Probably you got confused from these two MOSFETs. But all you have to know is the resistor is the output into the main power rail, always. So this resistor, that's the output to the main power rail. This one you have to understand it later on how it works.
Which one is this?
This is a Dell. It's completely different. So this one it will first have this to bring in the 19 volts. Then it has another set of MOSFETs which then convert that 19 volts to 13 volts or 12.5 volts. So that's where your main power rail is, on that 12. It's not on the 19. But most of them in general, MOSFET, what's happening? MOSFET resist. Your main power rail starts on that resistor. So what's happening when we get to the resistor? Let's probe there. You've got 0 ohms. You've got ground on your resistor. So I don't even know why you guys, it took you about an hour to find out and you still came out with the wrong answer. Something which took me less than 5 minutes to figure out.
Like 3 minutes.
So always, if you're facing a dead laptop, follow the power. That's how you fix a laptop. Follow the power. If it's dead, that's the one thing which you should always accept with a smile. A dead laptop, because you follow the power. I'll pause. You can take your call. I think Nilambile, you're probably hungry. Anyways, I've explained to you. The motherboard, you have to see the general color of the motherboard. So you can see the general color of the motherboard. Then you've got these. These are your lines. You can see that's one line there. That's another line. That's another line. Those are the lines. So that's where it means that's where the circuit is, where you see those lines. Anyways, your main power rail is starting there, as I've already said, and you've got a short circuit there. So what happens when you inject voltage? That's how you kill a short circuit. You inject voltage to it. There.
If you don't have that machine, how can you do it?
If you don't have this machine, you can use this one.
Which one?
The power supply. Yes. If you don't have both, then you have to do one by one, which means you have to find each and every component which is on the main power rail, lift it up, lift it off, remove each and everything. So that is not practical. It is not practical at all. But there are instances where you are forced to do that. We will get to those later on, but sometimes you have to remove one by one, especially if your short circuit is on a power rail which is very low. Say maybe it's on the CPU power rail. CPU only works at like 0.9 volts to 1.2 volts, some of them, I think. So that voltage is very low. When you start injecting a voltage of like 1.5 volts, instead of getting heat from what state, you're going to start burning stuff on that motherboard. Anyways, let's continue. So let's inject voltage now. Where is that caterpillar phone?
Yebo baba. Babunyati.
Ima kancane kutofi, ima kancane. Ma sesiyarekhoda la. Sisashuta ivideo. Ufuna uphuma video? Anyways, let's go to the thermal camera, no? So with the thermal camera, it's very simple. First, try to have a general temperature of the motherboard. You can see most of the motherboard is around 24 degrees. And this area is around 26, 25, 24. So that's the general temperature of the motherboard. But what happens when I inject voltage? You can see something is getting to like 34 degrees here. 36, 37. So that's where your problem is. If you check all around the motherboard, the temperature goes down. 24, 22, 25. But when you come back here, it's hot. So whatever is dead is somewhere here. And it's getting hot. It's really hot here. But it's on the other side of the motherboard. Somewhere here. So let's inject the voltage again from this side. So we have to find a place where we've got a short circuit, no? So I'll go to ground here. Even though I already know it's around this capacity there. So I can inject over there. So we already know it's generally somewhere here, so I don't need the thermal camera anymore. And it's this chip here.
How did you come to that conclusion? Is it
because it's heating up. No, actually it's on this cap, the capacitor that I'm injecting on. So the easiest way to do that, you could spray alcohol, or you could just put flux. Flux is solid mode. When you inject voltage to it, when you put it on something hot, it will melt. There, you can see it's melting away. Let me come even closer with the camera so that it can be visible. There. You can see it's melting all the flux away. So a problem is somewhere over there. It's either it's the atmosphere or it's at capacity. So we'll start with the capacitor. It's the easiest to remove. Okay, I'm gonna remove these ones because here they will turn. Awa. Here's Ulambiro. Okay, that capacitor is off now. Let's see if our short circuit is still there. Okay, you no longer have a short circuit. That's ground. Now that's positive without a short. So we can come and check it this side. On the so when we come and check here, we no longer have a short circuit. Doesn't beep anymore. The beeps on ground no longer beeps. And what happens when you plug the charger? DC power supply. You're no longer getting a short anymore. And you can see the motherboard is on, fully running. If you've got a fan with you, where's the fan? On the screen. It's fine. Let me put it here. Let me put it to the monitor. It should display for us, but you can find the fan first, because the fan we want to see it spinning. And there you go.
The display.
Yeah, wait and see. It's already responded there. So you should give a picture anytime soon. Default put device is missing. Sim.
It's on.
Can I get the keyboard? Yes, keyboard. Yeah. There. This USB port is broken. Alright, let's go F1, F2, Control Delete, and then we'll go F1, F2 to see in BIOS. There, you can see the machine works. It's an Intel processor U300. I have no idea what processor that is. 16 gigs of RAM. What? Fixed. Breaking. You can put it back in the casing and give to the customer. Simple as that. You are only supposed to follow the power.
So when you remove that,
a capacitor, remember, that's why I said go and do your research. You guys are not doing your research. I cannot be teaching you about capacitors and resistors, what they are theoretical, because you should just know that. You should go and do your research. A capacitor gets connected, one leg on positive, one leg on negative. So when you remove a capacitor, it doesn't affect the circuit. But when you remove this MOSFET here, the power will get to the MOSFET, but it won't go to the other side because there's nothing there. It's different with the capacitor, which is connected like this. So this would be your negative. Now let me remove this because we're done with it. Let's say this is your that's your negative and that's your positive. Let's assume there's a capacitor here, right over there, and we can name that maybe capacitor 2. If you remove this, you didn't affect the positive line, so the machine will still work. But remember, the use of the capacitor is to make the current smooth and to store charge. So if it's not there, that function will not be there. A machine can misbehave. If it's a laptop, let's say you removed from the CPU, you'll find that it just misbehaves, or sometimes it glitches or things like that. It happens. So you are supposed to replace them. Although most of them which are on the main power rail, it still works even if it's not there, because there's a lot actually. Especially if you find one where they've got 3 of them in line. If you remove one, then it doesn't really affect. But yeah, you should replace. That's my advice. That's it for today. Goodbye.